Hello, this is Algebra 1. This is Unit 1, Day 1, Lesson 1. This is the very first video that I've made, and we're about to go over the very first day's lesson that you may just want to look over again, or maybe you missed. We started off with a warm-up, which had 3 questions. Each question was a little bit different. So this is all about algebra. Algebra is the study of finding unknown things. And that's what we're trying to do here, trying to find what is the value of x. X is our unknown. So in the very first question, we call this a one-step equation, and we call it a one-step equation because it takes literally one step. We see that x is being multiplied by 6. I'm going to do the opposite operation using what's called the division property of equality. And I'm going to divide both sides by 6 because anything divided by itself is 1, and it basically cancels itself out. So leave me with just x on the left-hand side. But whatever you do to one side, you must do to both sides. So therefore, 18 divided by 6 is 3. So now we know that x must be 3. Now, the same thing goes for question number 2, but question number 2 is a two-step equation, which means it's going to take 2 steps in order to solve it. 2 properties that we've talked about in class. Always do addition and subtraction before multiplication and division. So I'm going to do the opposite of subtract 10, which is to add 10 to both sides. And this is the addition property of equality, because you're doing the same thing to both sides. When you add 10 to negative 10, that makes nothing. That's the whole point, to get rid of it. That leaves you with 3x on the left-hand side that I brought down, didn't do anything with it, is equal to 12. Now, from here, we can now use the division property of equality because x is being multiplied by 3. So I'll do the opposite, which is divide it by 3. And that is going to give us an answer of 4. X must be 4. Now, question number 3 has multi-steps. In fact, we call this variables on both sides. The reason why is because there are variables on both sides. So first thing I want to do is I want to get the variables on the same side. So I'm going to eliminate x from both sides and get both of the x's on the left-hand side. So that leaves me with 7x minus 10, which I bring down. I didn't do anything with it, equals 11. Now, if it seems like I'm having a tough time writing, it's because my writing utensil wasn't working. I'm trying to write using a mouse, which is making things a little bit difficult for me. So I'm going to now add 10 to both sides to get rid of that minus 10, because it's the opposite operation. That's the addition property of equality, which is going to leave us with a balance of 21 on the right-hand side. Yes, I said 21. Some of you are probably laughing right now. So equals 7x on the left-hand side. Use the division property of equality, and you can see that x is going to be 3 once you divide both sides by 7. So I'm just going to, for the sake of time, write the answer over here. I kind of ran out of room there. Now I could take this answer, plug it back into the equation, and see that that is the right answer. That would be checking my work, which is always a good idea, but for the sake of saving time, I'm going to move on. Now, on the next thing we did in this lesson was we did this activity where we were writing let statements. We're writing things such as let x equal the amount of squares in each set. And then we could say y is equal to the amount of circles in each set. So we could say that there are 3 squares in each set and 2 circles in each set. So then all I'd have to do to write an expression is write how many sets there are of each. So that'd be 1, 2, 3, 4, 5. 5x plus 5y would be my expression. Now, that's not the only way you could do it. You could also write let x equal anything you want. So there are multiple ways of writing let statements. All right, so now getting into the activity. The activity was about, can you write an expression that's going to represent this checkerboard activity? So there are lots of shaded tiles, and you're supposed to figure out what would be an expression that represent all of it, no matter how big the rectangle is on the inside of the shape. So you could split this up any way you want. I, for instance, could choose this being the same as this. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 shaded tiles in this circle, which means there's 9 shaded tiles in this circle, and then that would leave this section and this section, which both have 5. Now, you might have done it differently, which will give you the exact same results. 9 plus 9 makes 18, plus the 10 from the 2 5s makes 28. So there are 28 shaded tiles. So then the next thing we were going to do is figure out, well, what if the inside square was any size? What equation, or what expression, could you use to represent any size square on the inside? So S could be any amount. So what we do know is that in this spot, which I said 5 a second ago, we do know that whatever this length is from here to here is always the same as the amount of tiles in that section. So if this is S, representing any number, then we also know that this has S amount of shaded tiles, which means this also has S amount of shaded tiles. So now on the left and right hand side, it's going to be a little bit more tricky because they have S from here to here, but they also have 2 in each corner. So this expression would be S plus 4. And the reason why it's 4 is because there's 2 in this corner and 2 in this corner for a grand total of 4 more than the one side of just S. Now, if that side is S plus 4, then I know what you're thinking, that this side must also be S plus 4, and that's because it is. Now, if you take all of these expressions and combine them, you've got one expression that will represent any amount of tiles, no matter how big the size of the square is on the inside. It will work for anything. So that is very useful. All right, so then that gets us to the homework. In the homework, it says each square represents one tile. How many tiles are in step 5 and 6? Well, it'd be helpful if we know how many tiles there are in each step. Step 1 has 1, step 2 has 4, and step 3, it looks like it has 2, 4, 6, 7. All right, each square has one tile. How many tiles will be in step 5? Well, it looks like we added 3 tiles here. To get from here to here, it increased by 3 tiles because they added a tile both on top and on the left and the right. And then here to here, they also increased by 3 as well. So it looks like the pattern is plus 3, which would be an arithmetic pattern. So if I continue that pattern, step 4 is going to have 10 tiles, and step 5 is going to have 13 tiles, which means step 6 is going to have 16 tiles. How can you determine the number of tiles in step 25? Now, I don't want to continue this, even though I can keep adding by 3, but that's going to take me quite a long time. So I need to find a more, let's just say an easier way of finding that answer. An easier way would be to find the expression. The expression is always the amount being added to the pattern, which in this case is 3, multiplied by the amount of times that you added it. So in order, for instance, to get to step 3, you had to add it twice. So that's 2 times 3 would be adding 6. Plus whatever you started with. In this case, we started with 1 block. Now, if I use that expression and I put 25 in for x, x is the amount of steps, 3 times 25 would be 75, plus 1 means there would be 76 tiles in the 25th step. So this is the equation I would use, and the answer would be, as just previously mentioned, 76 tiles. If you have any questions, please feel free to ask me. I will keep making these videos in the future, and I'll try to keep them as short as possible so that you can get the help that you need without a whole lot of time. Thank you very much for watching, and have a great day.